Hi, my name is Mudinda and I'm here to help you understand maths better for free. Today, we're looking at a past paper or past exam example on trig graphs. This is the first question. I have two questions for you, and I want to advise that you try the question first and then compare with what we have. Or maybe try the first one, look at what we have as an answer, try the second one, look at what we have as an answer, and so on and so forth, because you can only learn maths by doing it. Let's get into it. So we're told the following here, that the graphs of the functions f of x is equal to a cos b theta, that is f over here, this guy, and g, which is c tan theta, that's this guy over here. We are given those graphs and we're told they're drawn here for this domain, and you can see that it's starting from minus 180 to 180. They're sketched below and they intersect at P and Q. P is this guy here with coordinates 58 and 1,6, as well as Q with no coordinates yet. That's Q over here. So the first question says 6.1, write down the range of f. Now f is, like we said, this guy over here. Now the range is the y values where the graph exists. If you look at the diagram, you'll see that the graph exists between the y value highest is 3 and the lowest is minus 3. And so to answer 6.1, we would say y is an element of starting from -3 and ending at -3. Like alternatively, you can answer this as saying y is less than or equal to is greater than or equal to -3, less than or equal to +3. Okay, you can choose one of these. In 6.2, the question says if m had the coordinates, and this is m over here, -45 is to -1, okay, and it lied on the graph of g, that is this tan graph over here, then determine the value of c. When they say determine the value of c, they're talking about this c up here, because they said that the graph of g is y is equal to c tan theta. And now they're telling us that that graph passes through the coordinates -45 degrees and -1. In other words, when x is -45, or when theta is -45, y is -1. We can substitute this point into this graph. Wherever we see theta, let's put -45 degrees. Wherever we see y, let's put -1. So therefore, -1 is equal to c tan of -45. Now, how does this help us? Well, as you can see, the only unknown here is now c, and we can solve for c. Now, if you take your calculator and check the tangent of -45 degrees, you'd get that that's -1. So -1 is equal to c multiplied by -1. If you divide both sides here by -1, you'd get that therefore c is equal to +1. Okay, so that's how we would answer finding the value of c. And another thing you should know is that therefore now y is equal to 1 tan theta. So this is the actual equation for g of x. G of x is equal to tan theta. It's the original tan graph. You don't have to write that out. The question is only asking you for the value of c, so that's where that stops. 6.3 says, determine the value of a and b. Now, when they speak of a and b, they're talking about what's going on here, okay? This is f of x, the cos graph, is equal to a cos b theta. Now, we discussed in the previous video what each of these parameters mean. We just need to determine a by checking if this graph has been stretched. We know that a determines whether the graph has been stretched. Now, look, the middle way is right here on the x-axis, and the highest point there is 3 away from that point. The lowest point there is 3 away from that point. Okay, so we can see that indeed this graph has been stretched by 3. So in order to answer what the value of a there is, we'd say a is equal to 3, because the graph has indeed been stretched. In the previous video, we spoke about how b has to do with the period. So in our graph here, we need to inspect it and determine what the period is. We're going to try to determine when it starts repeating itself. The graph starts here at 3, right, and 0 degrees. Then it goes down until it gets over here to the x-axis at 90 degrees, right? Then it goes down again, 180. This graph is going to keep going up, and right here at 270 it will touch the x-axis. Then it'll keep going, and it'll complete itself at 360. I hope that you can see that pattern that it's following there. So we can now see that the period is 360. Now, you will have noticed from the last videos that we said period is always equal to 360 over b. Now, if the period is 360, that means 360 is equal to 360 over b. Now, 360 times b is 360b is equal to 360. Dividing by 360 on both sides, you'd get that therefore b is equal to 1. Okay, this should ring a bell from our previous video. If you haven't watched it, give it a watch. It'll help you understand how trig graphs work. Great. Awesome. Now, grade 11's matriculants. Let's talk about 6.4. 6.4, and maybe before we do, because we found a and b here as 3 and 1, then f of x is actually 3 cos of theta. Now, this is not necessary for the question. The question only asks you to write down the values of a and b, which we did there, 3 and 1. But just for your note, 6.4 now says determine the coordinates of q. That's 6.4. Now, I love this question because it brings up a point that I couldn't mention in the previous video unless we had an example like this. And this is a point about how all these graphs are just patterns that keep repeating themselves. So this graph is going to keep going this way forever. It's going to keep doing that. The tan graph is going to keep going this way and again there, with asymptotes oscillating between these. Okay, so these are just patterns that keep going on forever and ever indefinitely. They've just chosen to show us a portion of the Cartesian plane to focus on between negative 180 and 180. Now that said, there are 2 points of intersection, this one here and that one there. But because these are all oscillating or repeating patterns, we need to keep in mind the following. The distance between this point of intersection here and the asymptote should be the same distance between this point of intersection and the asymptote, because these are patterns that keep repeating themselves. What is the distance from P over here to 90 degrees? Well, the x value at P is 58. The x value here at the asymptote is 90 degrees. Now, 90 minus 58 is 32 degrees. So from here to here, you move 32 degrees. From there to there should also be 32 degrees. So the x value of this guy here should be 90 degrees plus 32 degrees, which is 122 degrees. What about the y values? Well, between the x-axis and the point of intersection there, we have 1,6. That should be the same here, which would mean that here we have negative 1,6 as a y value. So to answer 6.4, Q has the coordinates 122 degrees, negative 1,6. They love asking a question like this regarding the points of intersection. Keep in mind that these are patterns that repeat themselves, so the distance between here and there should be the same as the distance between there and there. The distance between there and there should be the same as the distance between there and there. 6.5 then says if K, now K is this guy here, if K lies on F, which it does, such that Km, this line, is parallel to the y-axis. Parallel to the y-axis just means a vertical line. Remember, the y-axis is a vertical line. If you're parallel to the y-axis, you're a vertical line yourself. So they're saying if Km is a vertical line, then determine the length of Km. Well, Km is just a vertical line. So the length is the y value at the top minus the y value at the bottom, or the y value at K minus the y value at M. So that is 2 because the y value at K is 2, minus negative 1 because the y value at M is minus 1. So the length of Km is 2 plus 1, which is 3. Now, grade 11's matriculants, 6.6 asks a really interesting question. It says, if the system of axes, that is the y-axis and the x-axis, if those are shifted 45 degrees to the left, just imagine that. Imagine you picked up the x and the y-axis and you shifted them 45 degrees to the left, but the graphs remain fixed. You left the graphs as they are. Write down the equation of the graph that is now represented by f. Let's talk about this. Firstly, what is this question not saying? Okay. Last time we spoke about shifting graphs left to right, shifting graphs horizontally, and we said if you were to shift f, if f was shifted 45 degrees to the left. Now, this is not what this question is saying. But if it was, if f was shifted 45 degrees to the left, and remember f of x is 3 cos theta, right? If it's shifted 45 degrees to the left, it would become 3 cos x plus 45 degrees. We spoke about this in the last video, that if it's moved to the left, would say plus 45 there. If it was moved to the right, would say minus 45. But the question is rather saying, if the system of axes was shifted 45 degrees to the left. And I'm going to tell you what it means to shift the axes 45 degrees to the left. And I want you to maybe even pause the video and think about it after I say it. Shifting the x and y axis 45 degrees to the left does the same effect as shifting the graph 45 degrees to the right. It's the same thing. Shifting these axes 45 degrees to the left has the same effect as moving the graph 45 degrees to the right. Give it a thought and try to imagine if we shifted these axes to the left, right? It would be the same as the graph is now shifted to the right. Okay, so if axes are shifted 45 degrees left, the effect is same as graph shifted 45 degrees to the right. And therefore, the new f of x is 3 cos of x minus 45 degrees. So this is the new equation of f. Let's look at another past paper. So, grade 11's matriculants, let's look at the next past paper. Now this question starts by asking you to determine the general solution of something. It has nothing to do with trig graphs, right? It has to do with trig equations, general solutions. Now, I've made a very good, if I do say so myself, a very good series of videos on how to solve trig equations. Now, we are going to solve this one because it's actually going to be quite necessary for some of the other trig graph questions. Sine x minus 30 is equal to cos 2x. Sine x minus 30 is equal to cos 2x. In our trig equations videos, we looked at the fact that to answer a question like this successfully, you might want to implore cofunctions by changing this guy to become the sine of 90 degrees minus 2x. Then we said you might want to consider that this is technically us looking for where sine is positive, which is there and there. Now this would be represented by just dropping the trig ratios and equating them to one another. X minus 30, or equating the angles rather, x minus 30 is equal to 90 minus 2x. Then you would add 360 degrees times k. The other option would be to again equate x minus 30 to 90 minus 2x and add 360 plus k. But because we are now looking at that quadrant, we would say 180 degrees minus that. Okay, we look at this in detail when we do trig equations. So if you haven't watched that video and you struggle with these, please give it a watch, okay? But for now, you can stop worrying about this, and once we get to the end, only worry yourself about the questions that have to do with trig graphs. So the answer here would be that negative 30 degrees plus 90 is equal to negative 2x, or rather, let me move the 2x to the side so that we have 3x is equal to 90 plus 30, which is 120, plus 360k. And if I divide everything by 3 here, then x would be equal to 120 over 3 should be 40, right? Yeah, 40 degrees. And then 360 divided by 3, that's 120 plus 120k. Okay. On the other hand, we have x minus 30 is equal to 90 degrees minus 2x, or plus 2x. Okay. Plus 360k. And so negative 30 plus 90, that is 60. So 60 degrees is equal to, on the other hand, we have 2x minus x, which would be x. So x is equal to 60. Okay, so x is equal to 60 plus the 60k. Great. We're going to leave this here. This is the general solution. And 6.2 then says the following. Consider these two functions. This is the sine graph, right? But it's been shifted 30 units to the right. This is the cos graph, but b is 2. Okay. 6.2.1 says the following. Write down the period of g. We know that the period is always equal to 360 over b. So you can see there with g, b is 2. So the period is 360 over 2, meaning the period of this graph is 180 degrees. 6.2.2 says state the range of f. Now, have a look here. This is f. Now, the original sine graph looks like this. Its range is just from -1 to 1. That's the y values where it exists. If we shifted this graph 30 units, if we shifted this graph 30 units to the right, would that affect the range? No. The graph would just start here. Its highest point would be here. It would look something like this, just shifted 30 degrees to the right. The range would, however, remain the same. The range is just y as an element of being between -1 and 1. Or you can say y is between -1 and 1, like that. Okay, it's up to you which one you choose. Now grade 11's matriculants, the next question, 6.2.3, asks us to sketch both graphs. So on the grid provided, draw the graphs of f and g on this domain. Clearly show all intercepts with the axes, the turning points, and the endpoints. Now, we know how to sketch graphs because we always just compare them with the original. So in our case, in terms of the sine graph f, it's almost exactly the same as the normal sine graph, like that, but shifted 30 degrees to the right. Okay. So instead of starting at the origin here, it's going to start here at 30. Instead of its highest point being at 90 degrees, it'll be at 90 plus 30, which is 120. Now, instead of it returning to the x-axis at 180, it will return at 180 plus 30, which is 210. Instead of its lowest point being at 270, it'll be at 300. And instead of completing itself at 360, it'll complete itself at 390. This black graph is the graph y is equal to sine, or f is equal to sine x minus 30. It's the sine graph shifted 30 degrees to the right. Okay. Just keeps going like that. In green, I'm going to draw the other graph, cos 2x. G cos 2x is almost the same as a normal sine graph, a cos graph, but the period is no longer 360, but it's 180. So it'll still start here at 1, but its lowest point, instead of it being at 90 degrees, which it would usually be here at 90, and then the lowest point would be at 180, then it'll touch at 270, and so on and so forth. Instead of doing that, its lowest point will be at half of 90, because the period has been halved from 360 to 180. Half of 90 is 45. So at 45 degrees, it'll cut the axis there. Sorry, not the lowest point, but where it cuts, it'll be at 45. Okay. its lowest point, instead of being at 180, would be at half of 180. So it would be at 90. That's somewhere here. Okay. It'll cut again. Instead of cutting at 270, right, it's going to cut at half of 270, which is 135. So somewhere there. And then its highest point, or it repeats itself, will be at 180 instead of 360. Okay, so that's how the graph would look. Just like that. Let's also indicate that this is, okay, but before we do, remember now there is a domain they're asking for. They want us to look at this between negative 90 and 180. Between negative 90 and 180. Let's go back to our sine graph, okay? We want, it started here at 30, right, instead of at 0. Now, its lowest point on this side would usually be at negative 90, right? But now, it's going to be at negative 90 plus 30. So the lowest point on that side would be at negative 60. Okay, so this would be at negative 60. Just comparing it to our normal sine graph, okay, negative 60. And then it would usually, from there, come back to the x-axis at negative 180, but now it's going to be at negative 180 minus 30. Okay, and that would be at negative 210. Okay, so negative 60 and negative 90 would just be somewhere here. So we don't need to draw any of that here. Just need to stop here. Okay, something like that. With the green one, it's going to keep going as well, going all the way down, and usually it would come back to touch the x-axis at 90, but it's now going to do so not at 90 but at 45 degrees. So somewhere right here at 45 degrees, it'll touch the x-axis. So this is at negative 45 degrees and 0. And then its lowest point would, instead of being at negative 180, it'll be at negative 90. So right here at negative 90 and minus 1, there would be a point. And that would be all that we see of that graph. Now the upper bound was said to be 180. So everything post 180, remember this graph completes itself at 180. 180 degrees is to 1. Everything post 180, we don't have to see. That is the sketch, okay? Everything post 180 we don't have to see. That's the sketch. But you have to also show all of these points. Right here, instead of this being at, so that's the cost graph, instead of it cutting at 180, it now cuts at, wait, its lowest point was at 90. Oh, what is 90 plus 45? 135. So this is at 135 degrees is to 0, okay? When it completes itself at 180 is to 1. So that's the kind of sketch you want to be thinking about, is how can we shift these graphs accordingly. Now, it's going to require that you be very comfortable with how the original graph looks. The last one, 6.2.4, says write down the coordinates of the points of intersection of f and g in that interval. Points of intersection. Okay, so we have a point of intersection somewhere here. Looks like it's between minus 90 and 60. We have another one here. We can see it's between 30 and 45. And we have another one there. Looks like it's between 135 and 180. But we've also done 6.1, which helped us to find the points of intersection by equating the two graphs. We had 40 plus 120k. We also had 60 plus 360k. 40 works, so if k was 0, 40 would be one of the solutions, right? So 40 works because it falls within that interval 90 to 180. 40 degrees works. What else though? 60 degrees also works, okay? 60 works. Now, what if k was 1? That would mean 40 plus 120. Now, 40 plus 120, that gives me 160. Is 160 in this interval? Yes, so 160 is one of the solutions that works. Okay, and what about if we added another 120 would be beyond 180? Okay, but if we subtract, so if k was minus 1, if we subtracted 120, 40 minus 120, that's about negative 80 degrees. Does that fall in there? Yes, it does. Negative 80 degrees works. Okay. But if k was negative 2, so if we subtracted 120 twice, so 40 minus 120 minus 120, that would give me negative 200. And this doesn't work because it is not within that interval. Oh, I'm actually, yeah, that's fine. And here, what if you added 360? Then you'd have like 400 and, 420. That's too big. Doesn't fall in the interval. And even if you subtracted 360 from here, you'd have negative 300 degrees, which also doesn't work. These would be the possible solutions, okay? Because those fall within the interval. All right, so I hope this helps, and I'll see you in the next one.